So I claim that there is not a unique solution to this problem, and the way we can do this is we can start by using a 2 by 2 matrix. I'm going to call it matrix A, B, C, D, where A is top left corner, B is top right, and so on. We can sum up over each column. We get A plus C is equal to C1, the sum of column 1. B plus D equals C2, the sum of column 2. A plus B is equal to R1, the sum of row 1. We start summing along the rows. And C plus D is equal to R2, the sum of row 2. At this point, you'll notice that we have a system of linear equations, so we can rewrite this as a matrix. So my first equation becomes 1, 1, 0, 0, the top row of my matrix. We multiply by the column vector variables A, B, C, D, and this should result in the sum R1. And I can do this for each equation here, right? So C is going to be this third column, D is going to be this fourth column, the second row represents the second equation. And I do this for all of these equations here. Once it's written in matrix form, in order to determine if this has a unique solution, I can start row reducing. In this case, instead of doing a full row reduction, I'm just going to perform a few elementary row operations and show why this is not going to be unique. So first of all, I can sum row 1 and row 2 together and make that the new row 2. Likewise, I can sum row 3 and row 4 together to get the new row 4, and it results in this matrix. So you can see now the second row is all 1s, the fourth row is all 1s. In other words, row 2 is equal to row 4. And what this is going to imply is there's no unique solution. Because if those two rows are equal, then there is either going to be no solution, or there's going to be infinitely many solutions. In this case, if we have meaningful numbers, it should always be infinitely many solutions, because when we sum the first two rows together, we're taking the sum of all the elements of the matrix. If we sum the first two columns together, we're summing all the elements of the matrix. So R1 plus R2 should be equal to C1 plus C2 if the question is well posed.